Okay, in question 5b, again, it's a synthesis related question. We know that pentane 1,5-diamine synthesized in 2 steps, starting with an appropriate halogenopropane. Propane stands for 3 carbons, and the name pentane 1,5-diamine stands for 5 carbons. So we're supposed to name the appropriate starting halogenopropane. Okay, so you can see from 3 carbon to 5 carbon, based on what we've discussed, we need to step up. And in this case, we need to step up 2 times. Step up 2 times means we need to replace with 2 Cn minus. Alright? How can we replace with 2 Cn minus? When we have 2 halogenal alkanes to replace. Can so far? Okay, so you imagine if I need from a propane, right, 3 carbons, I need 2 halogenal alkanes. Alright? So imagine if I replace this with Cn, alright, 1, 2, 3, 1, 2, 3. You can see now I increase the carbons to 5 carbons. And then when I just reduce the Cn to amine via lithium aluminum hydride, I can get my compound. So this is therefore the halogenopropane I need. It will be at 1,3 position, 1,3-dibromopropane. Okay? So you can see the reagents and conditions required. 1,3-dibromopropane, I use ethanoic KCN, I'll get my Cn attached to both ends. Alright, this is a nucleophilic subreaction. And all I need to do is to get the product, which is your pentane 1,5-diamine. I just have to reduce my Cn to my amine, which is lithium aluminum hydride dry ether reduction. Or you can use hydrogen gas, whichever the case is. Okay? So it's not that difficult. Okay, you're supposed to draw the displayed formula of the intermediate form in the first step. So the intermediate, this is the intermediate. Alright, in this case, the intermediate for synthesis is like the in-between products. Okay, so you're supposed to draw the displayed structure formula, right? So displayed structure formula, all you need to do is just to expand out. C triple bond N, C triple bond N. Okay, so that's a displayed formula for part 3. Okay, can? If not, we'll move on to the last part of 5b. Okay, so from the same halogenopropane chosen in part 1, propose a 2-step synthesis route to produce bromoethanoic acid. Now, what's bromoethanoic acid? This is bromoethanoic acid, stating clearly the reagents, conditions, and intermediate. Again, the intermediate is not the carbocation intermediate. The intermediate is basically what is the in-between step before we get a bromoethanoic acid. So take a look. We start from a 3-carbon halogenal alkane to a 2-carbon. So remember how this is a step down reaction. The only step down reaction you learned so far, it's your CC double bond cleave. So how can I get CC double bond? I need to therefore eliminate out, right? I need to eliminate the HBr. So how can I eliminate HBr? What's the conditions required? I need ethanolic KOH heat, and that's how I get my CC double bond. Okay, then you can see that once I cleave the CC double bond with KMnO4, this fragment here becomes CO2 and H2O, and you end up with COOH. Okay, that's how I get my bromoethanoic acid. Okay, with that, question 5 is done.